So first we need to know how to name these compounds. Alcohols are anything that has a hydroxy group connected to it. And we'll do our naming in the same way. We'll identify and name the parent, identify and name the substituents, assign a locant to each substituent, and assemble it alphabetically. So first, we'll need to replace the suffix "e", like the pentane here, with an "-ol". So pentane will become pentanol. We'll want the parent chain to be the longest chain that contains the hydroxy group. So this, the parent chain, would be an octane. But here, the longest chain that has the hydroxy in it is 6 carbons long. And so we have a hexanol. We want to number the chain to give the hydroxy the lowest number. So the correct way to number this chain is 1, 2, 3, 4, 5, 6, 7. So you're going to give the double bond the number of 6. So this is the correct way. So you don't want to number it from the other end, because that gives the hydroxy a larger number. The locant, that is the number that tells us where the hydroxy is, can appear before the parent here, or we can put it in the middle of the word. I think it's a little neater to put it here. It makes it easier to say pentanol than the other way. When we have an alcohol that's in a cyclic compound, we'll name the carbon that it's attached to will always be 1. And in this case, we're going to go around in number 2 and 3 so that this dimethyl group will be 3. If we went the other direction, the dimethyl group would be 4, and that wouldn't be good. We don't want to do that. Many alcohols have common names, and I will not test you over them, but you will certainly see them if you're ever in the lab or have any dealings with chemistry. Isopropyl alcohol is 2-propanol. Tert butyl alcohol is 2-methyl-2-propanol, and benzyl alcohol is a phenylmethanol. Alcohols are designated as primary, secondary, and tertiary. A primary alcohol has only 1 R group. Secondary has 2 R groups, and a tertiary will have 3 R groups attached to this carbon here, which we are naming the alpha carbon. Phenol is the name for hydrobenzene, and it can also be used as a parent name. So we have here 4-chloro-2-nitrophenol. So here is our 1 carbon. Here's 2, 3, and 4. Let's assign a UPAC name to this compound. So we're going to follow these actually 4 steps. First, we'll find the longest chain that contains the hydroxy, and we'll start. Oops. We'll start here, and we'll go up because that gives us the longer chain. And we're going to number that chain so that the hydroxy gets a low number. 1, 2, 3, 4, 5, 6, 7, 8, and 9. We want to then identify the substituents and assign locants and assemble it alphabetically. So here we have a 4-dichloro, and this will be a 6-ethyl. Those are our 2 groups. We have a we know we've got a nonane. Nonane-ol, OL on the end, because it's a 9 carbon compound. If we assemble it alphabetically, we get a 4,4-dichloro-6-ethyl-3-nonanol. And then we need to assign the configuration of the chiral centers. Well, the hydrogen is coming toward us. This will be a number 1. This will be a number 2, number 3, and number 4. So we're going in a counterclockwise direction. However, because the 4 is going toward us, we know that it's going, we're looking at the back side of it, and so this would be an R. And I'm going to change colors for the next one, because I think that probably was real hard to see. If we look here, we've got 3 carbons attached. We've got a hydrogen that is going to be away. That'll be number 4. Let's see which one of these. We have to go out and look at the carbons here, here, and here. Well, they're all carbons. They all seem very similar. So we'll need to go one more carbon out. And this will be the number 1 because it's got a carbon attached to 2 chlorides. This is number 2 because it's attached to 1 carbon. And this is number 1 because it's attached to 3. It's number 3 because it's attached to 3 carbons. We've got number 4 is this hydrogen. Okay, and then we look. We're going 1, 2. We're going in a clockwise direction. We've got the hydrogen going away from us, so we're looking at it forward. So this one is also R, and so our name will be 3R, 6R, 4,4-dichloro, 6-ethyl, 3-nonanol. Important commercially important alcohols. Methanol is called wood alcohol. It's obtained by heating wood in the absence of oxygen, and methanol is poisonous. Don't drink methanol. Ethanol is a grain alcohol product of fermentation, and this is the alcohol that people drink. Isopropyl is rubbing alcohol, and it's used as a local antiseptic. It's the one you couldn't find when the pandemic struck. Okay. Physical properties of alcohol. We find that alcohols have higher boiling points than similarly sized alkanes and alkyl halides, and that is because of hydrogen bonding. This oxygen here is able to hydrogen bond to another alcohol, and the hydrogen is also able to hydrogen bond. And so that gives it a much higher boiling point. Ethane here, its boiling point is at minus 90, and chloroethane is at 12. So these are both gases at room temperature, and ethanol is, of course, liquid at room temperature. Small alcohols are immiscible with water. That means they mix without any separation, and it doesn't matter how much alcohol I add, you won't get any layering. But as the size of the hydrophobic region increases, the solubility in water will decrease. So a very small alcohol, like this methanol, is very soluble. A larger alcohol, like this, 1, 2, 3, 4, 5, 6, 7, like this 8-carbon alcohol, is very non-soluble or less soluble. Octanol has a low solubility in water. If you add 9 carbons or 10 carbons, it's completely insoluble.